Grace and peace to you all, and welcome back to my channel. This is Donald Siami, author of Hidden Mathematical Genius Within Revealed. The essence of this video is just to introduce the concept of beta functions. And beta functions is an extension of gamma functions. So this is the basic definition of a beta function. So it's beta of m and n is equal to integral from 0 to 1 of the product x to the power m minus 1 and 1 minus x to the power n minus 1 with respect to x. So the only difference between beta functions and gamma functions is that first the limits for gamma is from 0 to infinity. This one is from 0 to 1. Then the other thing is for a gamma function we have an exponent, and this one doesn't have. Okay, so this is the first definition, the basic definition, and I want us to drive the second definition of this beta function. Okay, so this definition will be in terms of trigonometry. So we are going to let the variable to be a trig ratio. Okay, so we are going to let x to be sine squared theta. Okay, so when we let x to be sine squared theta, the next step is also to find dx. We need to differentiate this so that we also substitute for this dx. So what is the derivative for sine squared theta? So we are going to have dx is equal to derivative for sine squared theta will be, these two come down, so we are going to have 2. Then derivative of sine theta is cos theta, then again sine theta. So the derivative for sine squared theta is 2 cos theta sine theta, and this is with respect to theta, so d theta. Okay, so when you change the variable, the limits must also change. So our initial limits were from 0 to 1. Then we have theta. So what will be the limits for theta? So when you put 0 where there is x, what will be theta? So sine inverse of 0 will be 0. So even theta will be 0. What if we put 1? So we are going to say sine inverse of 1 will give us 90 degrees, which is pi over 2. Okay, so limits. The new limits now are from 0 to pi over 2. Okay, so we have beta of m and n is equal to, so the limits we have from 0 to pi over 2. Then where there is x, you put a sine squared theta. So we have sine squared theta. This is to the power m minus 1. Then where there is 1 minus x, it will be 1 minus sine squared theta. And I believe you remember from trigonometry that 1 minus sine squared theta is cos squared theta. So we have cos squared theta. This is to the power n minus 1. Then where there is dx, we are going to have 2 cos theta sine theta, then d theta. Okay, so we have beta of m and n is equal to integral from 0 to theta. We need to expand this. So this will be 2 multiplied by m is 2m multiplied by 1, that is 2. So we are going to have sine to the power of 2m minus 2 of theta, and cos 2 multiplied by n is 2n, so 2n minus 2 of theta, and multiplied by 2 cos theta and sine theta d theta. Okay, then this 2 is a constant. We can divide it out. So we are going to have beta of m and n is equal to, so we have 2, then integral from 0 to pi over 2. So here we have sine of theta to the power 2m minus 2 multiplied by this theta. So when you have same bases, you add the powers. So the power here is 1. So it will be 2m minus 2 plus 1. You get 2m minus 1. So we are going to have sine to the power 2m minus 1 of theta. Again, here cos theta to the power 2n minus 2 multiplied by this cos theta, so the power here is 1. So it will be 2n minus 2 plus 1. Again, you get 2n minus 1. So it will be cos to the power 2n minus 1 of theta, then d theta. So this is the second definition of a beta function. So we are going to be using these two definitions of a beta function to solve questions. Okay, so the first definition is this one, and this is the second definition. Okay, thank you so much for your time.